All right, this is week 2, homework 1. I'm going to do a few of these problems along with you so you understand what the problem is asking you to do. Okay, if you look at question 1, it says write each rational number as a terminating decimal. We know from our notes that terminating decimals are any number that can be turned into a decimal that ends, that has a fixed ending to it. We know that there's 2 ways that we can get to a decimal. We can either get to our denominator of 100, or we can divide top in, bottom out in order to get to that terminating decimal. So I'm going to show you 2 ways on terminating decimals in order to do that. On 19/20ths, we can very easily get 19/20ths to get to a denominator of 100 by multiplying by 5. 20 times 5 is 100. Nineteen times 5 is 95. So if I was to read 95 hundredths, we know that that is the total percent. So if it was 95%, and to turn into a decimal, we'd write that as 0.95. The next way you can do this, if you don't have it memorized as to how to turn into a decimal, you can do top in, bottom out. So if we look at question 3, we can see that this is an improper fraction. So the top goes on the inside, 17. 5 goes on the outside. 5 can go into 17 3 times. 17 minus 15 is 2. Can't stop, so we put a decimal, bring down a 0, and 5 can go into 20 4 times. So you have one of 2 ways to do it. You can either get to a denominator of 100 and turn it into a decimal, or if you can't, such as the situation with 8, you would need to divide. With 17/5, we did top in, bottom out, and turned it into a terminating decimal. Now you'll also have numbers that are repeating decimals. So if I look at question 6, and I want to have a repeating decimal is a number, when turned into a decimal, that has a repeating pattern. So if I do top in, bottom out, and I put 3 into 8, 3 can go into 8 2 times. 8 minus 6 is 2. Put a decimal, bring down your 0. 3 can go into 20 6 times. 20 minus 18 is 2. Bring down another 0, and we can see if 3 goes into 20 again, that it's going to continue to be 6. Therefore, that is a repeating decimal. How I signify that is putting a line above it to show that that decimal repeats. Okay, on the next section it says write each mixed number as an improper fraction and as a decimal. Then tell whether the decimal is terminating or repeating. Okay, if we look at question 7, to turn into a mixed number into an improper fraction, I multiply the denominator by the whole number and add the numerator. So 9 times 3 is 27, plus 2 is 29 ninths. Okay, that's the first part. And now we want to write it as a decimal. So you may want to do this on the back or off to the side or on a separate sheet of paper and then just staple that to the original. You do need to show all work on this assignment. So if I put 9 into 29, 9 can go into 29 3 times. 29 minus 7 is 2. Can't stop, so I put a decimal, bring down a 0. 9 can go into 20 2 times. And it's going to keep repeating if I bring down another 0. So I would write this as 3.2 repeating. The next section says, then tell whether the decimal is terminating or repeating. Well, that sign right away is a giveaway that it is repeating. Remember, the difference is if it is terminating, it has an ending to it. All right, question 10. In part A and in part B, use each of the digits 2, 3, and 4 exactly once. I'll do one with you, you'll do one on your own. This is write a mixed number that has a terminating decimal and write the decimal. Okay? So to write a mixed number that has a terminating decimal, I'm going to look and see which combinations I could come up with. For this example, I'll use 2 and 3/4. Reason being is that would equal 2.75 as a terminating decimal. Okay? You will then do on part B, figure out a combination that you could come up with that would have a repeating decimal. Okay, so at this point we have done 1, 2, 3, 4, 5 out of the 11 questions together. Remember, this assignment is due Thursday for A day, Friday for B day. Thank you.